Hi, welcome back to the vlogs.
Okay. 6-2. Perpendicular and angle bisectors. Perpendicular and angle bisectors. Okay. So you have two theorems here. One is the converse of the other one. So it shouldn't be that difficult. Perpendicular bisector theorem says if a point is on a segment's perpendicular bisector, if a point is on the perpendicular bisector. So here is a perpendicular bisector, here is a point on it. Okay, perpendicular bisector, there's the point. Then it is the same distance from the segment's endpoints. So if I draw from here to here and here to here, okay, I have the same distance. So what type of triangle did I create? Oh, what?
Nope.
Isosceles, because the side lengths are congruent. So now I've created two triangles, which allows me to start solving things. Okay? So if M is the perpendicular bisector, then AP equals BP. The converse of that, what do you think the converse is going to say then?
The distances are the same.
If the distances are the same from a point to the endpoints, then the side lengths, then that point is on the bisector. Okay? So if a point is the same distance from a segment's endpoints, if this point is the same distance from this endpoint and this endpoint, then I know that point is on the segment bisector. Okay? So you have one that says if a point's on a bisector, then it's equal distance from the endpoints. The converse says if the point is equal distance from the endpoints, it's on the segment bisector. Okay? This has a lot of examples with it, and it has a construction that we're going to look at later, like with your compass and protractor, how to construct a bisector or something. You can't just take a ruler and draw a line down the middle. You have to actually show me by making arcs. Oh,
So complicated.
I know, who would want accuracy in life, you know?
Yeah, I know.
I'm giving you a second hustle there, Kayla. Korea is done. Okay, here we go.
You know what? Don't talk to me.
Ah, why am I
Talk to the L.
back one? Okay. Prove. Prove. Yay, prove.
Oh,
Prove that PA equals PB,
Wait.
given that PM is a perpendicular bisector of AB. What do I start with?
Can you just
The given.
I always start with the given. Beautiful. Boom. I know that segment PM is a perpendicular bisector of segment AB. Given. Okay, from there, what do I do?
Prune also say P and then P and B is a given.
What else is a given?
And angle P and B and angle P and
Okay, you want to say that angle M and angle, okay, angle PMB and angle PMA are what type of angles?
A. Right.
Right angles. Okay, we can do that. We can go with that. So the measure of angle PMB and the measure of angle PMA equal 90 degrees given, because you can see that on the diagram. Beautiful. I love that you use the diagram. Okay, what else can I do from there? What else do you know from that picture? You actually know two more things from that picture.
Would it be AP equals BP?
No.
AM and B?
Okay, you know AM equals BMY.
Because it's the same line.
Perpendicular bisector.
Because of the perpendicular bisector. AM equals BM because of the definition of a perpendicular bisector. It divides it into two halves, okay? Or you can say definition of a midpoint, either part, because that's the midpoint, doesn't matter. Okay, so definition of perpendicular bisector. So now I have an angle and I have a side that are congruent or equal. What else do I need to know? Another side, because then I can prove that the triangles are congruent using side angle side and then prove that the corresponding parts are congruent, PA and PB. What do you know from that picture? What else?
PM.
What's reflexive? PM equals PM, right?
Yeah.
Segment PM equals segment PM reflexive. Good. So now, I can't think. Reflexive. That's right. Okay, I just can't think for some reason. Thank you. Okay, so now I have a side, an angle, and a, so I can say triangle. PMA is congruent to triangle PMB, why? SAS. So then I can say PA, segment PA, equals segment PBY. No, they're not, has nothing to do with the
I
angle.
know.
If I prove that the triangles are congruent, what does that mean about their parts?
All sides are
What types of sides?
corresponding.
Corresponding. So PA equals PB because of corresponding, corresponding parts of a triangle. Okay, good, that was easy. What?
We just.
Okay. Whatever. Okay, perpendicular bisector and triangle. What is the slope of the perpendicular bisector of AB? You are told A is at -1, 2, and B is at 3, 4. What would be the slope of the perpendicular bisector of AB? What do you know about something that's perpendicular to something? It creates a right angle. What do you know when it comes to their slopes?
They're opposite.
They're opposites. So how can I figure out what the slope of the perpendicular bisector is when it's not even on this diagram?
Rise of
What?
it. Rise of it.
You flip them.
What do you mean you flip them?
Yeah.
What do you have to find? If all I'm given is the line,
Distance. Midpoint.
what is the slope
Oh.
of the perpendicular bisector of AB? Oh, so if you find the slope of AB, okay,
Yes.
what is the slope of the perpendicular bisector of AB? What can I do with that slope to figure out what the slope of the perpendicular bisector is? What? Yes, you just find the reciprocal. So if I know that the points are at -1, 2, and 3, 4, how do I set up slope formula?
Rise of it.
No.
Yeah, change in y over change in x. So, change in y is 4 minus 2, change in x is 3 minus -1, you get 2 over 4, which equals,
1/2.
so what is the slope of the perpendicular bisector of AB?
2.
-2.
-2.
Don't make the problem harder than it is. Don't make it harder than it
We
is.
totally just made it.
You made that very complicated.
We're teenagers,
Well-
we're supposed to make everything. True.
Okay, next. 2 more theorems. Angle bisector theorem and the angle bisector theorem converse. Like I said, these theorems aren't super hard. Okay. Angle bisector theorem says if a point is on the bisector of an angle, okay, if a point is on the bisector of an angle, then that point is the same distance from the sides of that angle. So, if y, or segment, not segment, if ray AD bisects this angle BAC, okay, and DB is perpendicular to AB, and DC is perpendicular to AC, then that means that DB is congruent to DC. So they're congruent to each other because they literally meet at the same point off of that angle bisector. Okay, point D is the same distance from the sides of that angle, no matter where you draw those lines. Point D is the same distance from here to here on that angle. Okay, doesn't matter where you draw those lines. Because it's in the center, because it's through the angle bisector, it's on the angle bisector, so it's through the center. Angle bisector theorem converse says, if a point in the interior of an angle is the same distance from that angle's sides, then it's on the bisector. So, if DB is perpendicular to AB, and DC is perpendicular to AC, and DB is congruent to DC, then AD is my perpendicular bisector of angle BAC. So it's just the opposite.
Your cup matches your shirt.
Mr. Thompson brought me lots of things. The lunch bag.
No.
Okay, so you have two theorems there. So basically, they're the same as the other theorems, the bisectors of a triangle that we talked about, except for this is with an angle. Okay, if a point is on that angle bisector, it's equal distance from both sides. If the point is equal distance from both sides, then it's on the bisector, is the converse. Okay. So, oh, they put it in pretty colors on this one. That's why I added this in here, because I thought it was easier to understand this way.
Pretty colors.
Okay, so it's the same exact thing, but I just like to see it visually a little bit differently. So it says, once again, that AD bisects BAC. That means that DB is perpendicular to AB, and DC is perpendicular to AC. Then DB and DC are congruent. I just wanted to see, I think colors sometimes help. This one says if DB and AB are perpendicular and DC and AC are perpendicular, then DB and DC are congruent, then AD bisects BAC.
Oh, Wheel of Fortune. One of those. The Wheel of Fortune people.
Okay, here's how we get a problem out of this. It says prove that the measure of angle MNP is 94 degrees, given that the measure of angle MNR is 47. Okay, so we're going to start with our statement and our reasons, and we're going to say the measure of angle MNR equals 47, because that is a given. Beautiful. Okay, now we need to prove that MNP, this whole angle, is 94. Okay, that's what we're trying to prove. How can I go about that? What else do you notice on this diagram? Good. So I can do that. I can say, let's see here. I know that angle M and angle P are congruent, yes? Okay. So angle M is congruent to angle P. Okay? Because that's also a given, it's on the diagram. And I'm just gonna put here 90 degrees so that I can see it and remember. Okay? What else do we know from this diagram?
Isn't it N over here the angle bisector for
Well,
M and P?
it is the angle bisector, but we don't know that yet, because it's not stated. What?
If all the sides, if the sides are congruent, then we just,
What sides are congruent?
and
What's
R,
MR and PR. Good, we have to state that. MR is congruent to PR, because it's a given, it's in the diagram. It's marked right here. Okay? So you have these markings. Now, what else can you state? What else is congruent? There's something else in that picture that's congruent. We can't prove that. Yes. NR. NR is congruent to NR, reflexive. Now. Reflexive. Now, what do you have going on there? How can you prove those triangles are congruent?
Because if it's reflected, 47 times 47.
What?
If it's gonna be reflected, wouldn't the other side be 47?
Yes, but we haven't proven that yet.
Is it side and side?
It's not side angle side.
Just like some.
You can't, you have to prove the whole thing. This is not side angle side. I have a side, and an angle. That's not a possibility. I have an angle, a side, and a side. That's not a possibility. I have an angle, and a side. That's not a possibility. But what is a possibility on a right triangle?
The
Hypotenuse leg.
Love you lots.
So triangle in MR is congruent to triangle in PR, hypotenuse leg. Beautiful. Now you can say that angle MNR is congruent to angle PNR. Okay? Okay. Angle NMR is congruent to angle PNR because of corresponding parts, yes? Then that means that angle PNR equals what? Equals what? 47 degrees. That is substitution. Then you have to create an angle addition postulate.
Yeah.
Okay, so then I can say angle NMR plus angle PNR equals angle, what was that whole angle? NMP? No,
Can you just go?
MNP, that was a genius. Angle addition. Then you have to do what? How about substitute? 47 degrees plus 47 degrees equals angle MNP, substitution. And so then that
Now
means,
you add them
yes.
together.
so you get 92, or 94.
Thank you.
Yep. Beautiful. And you just gave me a proof.
That was easier.
It is easier. Because you overthink the thing. You overthump. I don't know. The person.
Who to thumb?
Is that thing? I don't know things. Okay. Applying an angle bisector. Now, think this through. This is another way you can see this. It says, if the measure of angle CAR is 7 plus 2x, and the measure of angle CAT is 5x minus 16, what is the measure of CAR? They want the actual measure. CAR right here is 7 plus 2x, yes?
Yes.
This whole thing, though, is 5x minus 16. What do you know about the whole thing compared to the little part? If it's an angle bisector, what does that mean? It's half. So if I take 7 plus 2x, I set it equal to what?
Half or 1
Yes.
half times 5x minus 16.
1/2 of 5x minus 16. I can solve for x and then I can plug it back in and figure out what the angle measurement is. So I get 7 plus 2x equals 2.5x minus 8, yes? Subtract 2, add 8. So you get 0.5x equals 15. What is 15 divided by 0.5? What's half of 15?
7.5.
Right? No, I lied. It should be larger, right? 30? Yes, because you have to flip them over. 30. So you get x is 30. So I plug it in. And I have 7 plus 2 times 30. This is the part you guys always forget to do. Plug it back in and give me the real answer. So 7 plus
67.
That's what you're working on.
We know also most of it.
Oh boy. Okay.
Thanks for watching. Subscribe.
Like, subscribe to me down below. To me at David Dobrik. Anything else to add, Miss Peters?
Anything else to add, Peter?